Did you ever think about just how easy it would be to bring down a Cisco device? Think about the control plane. Think about how the CPU of the device has to get involved with the control plane traffic. Think about things you're running like OSPF and BGP. Think about the device that could be connected to you that's going to go ahead and flood your particular device so that the CPU is too taxed. Maybe it's just like false BGP updates, or maybe it's the flooding of OSPF hellos at your particular device. In this nugget, we'll take a look at how you can police your control plane to make sure these nasty denial of service attacks can't happen. Now, I'm going to make a promise to you throughout these nuggets, and that is if a particular feature is not where you might expect in the documentation, I'll go ahead and point out where it is. If you should have any questions about where a particular feature is and I don't cover it, just post that as a question in the comments area at my blog at ajsnetworking.com, and I'd be more than happy to find that feature for you. So here's where control plane policing is located. Support, all products of course, to get to the interface that you would have in your lab exam. We'll go iOS and we'll choose the iOS software option. And then once there, we'll go to our 15 M&T, 15.3, 15.3.2T, for example. And what you would probably do is come in the configuration guides, and if you're like me, you would look under security for this feature. Only you're not going to find it. Instead, we have to go to the quality of service area. You can remember this because, after all, policing is a form of QoS. So if you come under here and you go to the QoS policing and shaping configuration guide, you'll see we have control plane policing. That's our first generation technology. Then an enhanced generation called control plane protection we'll talk about, and then control plane logging. So here's the three sections you would be interested in for this particular feature. So we begin by taking a look at our first generation technology, just simple control plane policing. What I did here was I connected R1 and R2. On R1, I did a static route to the loopback on R2, and that's it really. So no fancy configuration other than making sure R1 could get to the loopback of R2. I also set up telnet capabilities on R1. So if we slide over to R2 for purposes of our testing and we telnet to 10.10.10.1, we can telnet into that device, no problem at all. Also, by the way, if we telnet using a source interface of loopback 0, the 2.2.2.2 address on R2, that works as well. So now we've got a nice test bed that we can utilize to check on our abilities with control plane policing. Since this technically, according to Cisco, is a quality of service feature, sure enough, we're going to use the modular quality of service command line interface in order to set up policing behavior against our control plane. So you remember the modular quality of service command line interface. It begins by identifying traffic in a class map. Now, the thing to watch out for with control plane policing is the fact that all of your robust match options are not going to necessarily be supported when it comes to using them against the control plane. For instance, on a lot of platforms, network-based application recognition, or NBAR, might not be possible when you're setting this up. I know one thing that's always possible though, and that is identifying traffic through an access control list. So let's do this together. I'll come in and I'll say access list 100, and we will deny TCP traffic from the host at, let's pick on 2.2.2.2, and this is traffic going anywhere, specifically telnet at port 23. So we are denying in this access list telnet traffic from a particular host. That's going to make it so that when we do our policing, it doesn't apply to that particular entity. So I'll do another access control list line here, and just for purposes of our demonstration, as we're practicing with this feature, I'll say permit IP any. So all other traffic is going to be subject to whatever we do with our policing. So now what we'll do is we'll create our class map, the first step of the MQC process. This is how we identify the traffic. I'll say class map CM underscore telnet, and I will match on the access group 100 to tie in our access control list. The second step of the MQC process is to create a policy map. So I'll say policy map, and ours will be called PM underscore telnet. Notice I'm using a naming convention that I can easily reference as I'm racing through in my lab exam. I will go ahead and call the CM underscore telnet class, and we see that we could police these forms of traffic to certain rates against the CPU. One thing I'll do just for purposes of our demonstration so we can literally see it with the naked eye is I will go ahead and I will drop traffic that matches the CM underscore telnet class. Now think about that effect as we look at the access control list. This particular host shouldn't be subject to this dropping. All other traffic to the CPU should be subject to that particular dropping behavior. Interesting. This is a crude example, but it's just one that we'll be able to verify. And when you're first learning a feature like control plane policing, you want that instant verification gratification. All right, so we've created our policy map now. Let's do this. Let's go and apply it. Where do we apply it? Well, that's what's so cool. We don't do it to an interface. We apply it to the control plane. So we go into control plane configuration mode and we do our service policy in the input direction. And of course, we have our PM underscore telnet. The minute we press the carriage return, the operating system will tell us, okay, you're doing control plane policing. You better believe it. So now we verify that this is functioning. We can go over to the R2 device. Remember, the 2222 address is an exception inside of our policy logic. So if I telnet to 10.10.10.1 using the source address of loopback 0, we expect it to work just fine, and it does. If we reattempt this telnet, though, with traffic sourced from who we were punishing, anybody else, the traffic should be dropped. And we can see that's exactly what's happening with our control plane policing behavior. So what about control plane protection functionality and logging functionality? Well, it's really the next generation of control plane policing. You see, here I am in the control plane configuration mode. I'll exit from that, and this time we'll say control plane ? And notice there's a host option, and we use this host option in the other device access controls nugget, and underneath the host option is where we can of course specify our management interface for management plane protection. Notice control plane host is manipulating traffic that is destined for this particular device. Ceph exception traffic is for layer 2 frames that are destined for this device, and transit traffic is for controlling traffic not destined for this device, but that is transiting it, that might be punted to the CPU. So we have this nice granularity at the control plane where we can now assign policing type of actions or logging type of actions. And this is done through special types of class maps and policy maps. Let me show you. So if we say class map type ? You'll see that there are specific types of class maps that we can create for the control plane functionality. There's a type of logging class map for control plane packet logging. There's a port filter class map where we can do cool things with port filtering, like maybe attack or address all of the open ports or all of the closed ports on our particular device. There's the Q threshold, where we can literally control what is in line for the CPU's attention, making sure that one form of traffic doesn't starve out other forms of traffic. So let me show you how this would work with a quick example. With this feature, we'll take advantage of network-based application recognition, and notice I create 3 class maps of type Q threshold, and we're using the match protocol nbar command to grab simple network management protocol, BGP, and all other host protocols. We are going to tie these class maps into a policy map, and guess what? The type of policy map will be Q threshold. So here you see I've created a policy map of type Q threshold named PM_policy, and we take each of those class maps we created of type Q threshold and we limit the number of packets that can be in that particular queue. How awesome! Now we assign this, of course, to our control plane. And when we're doing Q thresholding, the aspect of the control plane must be the host. So we will say control plane host, and then we'll say our service policy. Notice, though, we have to specify the type. So this is a type of Q threshold. It is in the input direction. Notice that's the only option for the assignment, and ours was called, of course, PM_policy. We've done it. We have indeed done control plane protection now with the great Q thresholding feature, and the status message at our console literally confirms that for us. And what would a port filter type configuration look like? Well, as you can see, here I'm creating a class map of a type port filter called CM ports. I match on the closed ports. I then create a policy map of type port filter, and I drop any traffic destined for the closed or non-listening ports on this particular router. How would we assign it? Simple. You would go into the control plane host sub-interface, and you would do a service policy of type port filter inbound to guard against these types of denial of service attacks. So it's so great to have options for controlling traffic on your Cisco router, and in this particular nugget we focused on controlling traffic involving your CPU. On model to model, you're going to have various levels of support for the features that I presented. So in some of your older devices, or in some style of Cisco devices, perhaps it's just the control plane policing. But on other devices, you'll have the whole host of options, no pun intended, that are available for things like control plane protection and control plane logging. I sure hope you found this nugget informative, and I'd like to thank you for viewing.